Hello everyone. Um, in this college algebra video, I'm gonna go through some type of equations that are different than the actual quadratic equations and the linear equations. Some of them are cubic, some of them is like higher degrees, but we may still solve them. They're special type of equations. I think 4 examples in here. Now the first one is just I listed this as an equation that can be solved by factoring. So by factoring, you simply try to factor out the highest, like the biggest possible factor on your equation. Like you can set one side equal to 0 for this one. Of course, for every problem you can pause the video and work it out yourself first. That's totally fine. We can move this term to that side as negative, so we have x to the 5 minus 16 x to the third equals to 0. Now as you see, you can factor out an x to the third from both terms. So we got x squared left in there and minus 16 left in there. In here you can, of course, just don't forget x squared minus 16. Feel like you can factor this as a difference of two squares, so it's like x minus 4 times x plus 4, which is fine, but you can also use it, solve it as a quadratic equation. So from here that implies x to the third equals 0, or x squared minus 16 equals 0. So here that implies x equals 0. That's one solution, and the other one is x squared equals 16, so x becomes minus plus 4. So those are the other solutions. So the solution set, you can write it as 0, negative 4, and positive 4. So we got 3 solutions in here. That's one type of equation. The other type is the one which can be solved by grouping. So again, as I said, you can pause the video and work it out yourself if you like before I solve it, and then you can come back and check the solution. So how does that work? When you solve factor by grouping, the point is that whenever you factor out a term or a constant from each term, then you should be able to come up with the same thing within the parentheses when you group them 2 by 2. Like let's say you group these first 2 and then the last 2. Now if I factor out a variable or a factor or just a single term from these 2 terms, like you can take out an x squared, and what left will be simply x plus 3. That's kind of like their common factor, and that's like the highest possible common factor. And from here I can factor out a negative 9. As you see, if I factor out a negative 9, I come up with x plus 3. See, this shows that factor by grouping works, because as you see, we got the same factor or same expression in the parentheses. So now we factor out this term, like this factor x plus 3 from the right. So think about, these are the reds that I'm factoring out from the right side. So what I left with is just x squared and minus 9. So I got x squared minus 9 multiplied by the red one, which is x plus 3. So that's equal to 0. So so what we have is, now from this factor we get from this part, let me just write it with blue, we got x squared equals 9, or in other words x equals minus plus 3, and from here we got, you can just say x plus 3 equals 0, so we got x equals negative 3. So if you combine all of them, then we come up with the solution set negative 3 and positive 3. Sometimes you may have multiple, like more than 2 solutions in here, but this is what we get for this particular equation. I hope these two examples are clear. So let's move to the next example. So in our next example, we have I hope these two examples are clear. We can maybe pause and take a look at them. But now we have a fraction. So we have x minus 3, and I mean x squared minus 9. Can write this right side as negative 12 divided by x minus 3 times x plus 3. Now you will find, first, it's a fraction. We have to get rid of all the denominators, so we need the least common denominator. Now least common denominator is the expression, or like the product of the factors, which includes all the factors that you can see in here. That's x, x minus 3, and x plus 3. So it's going to be x, x minus 3, and then x plus 3. See, that's like the smallest expression that includes each denominator as a factor. Now we multiply each term, each fraction in here by the LCD. So I have 3 over x multiplied by x times x minus 3 times x plus 3, and then I have 2 divided by x minus 3, again multiplied by x times x minus 3 times x plus 3, and at the right side I have negative 12 divided by x minus 3 times x plus 3, and this is also multiplied by x times x minus 3 times x plus 3. So we multiplied all of them by this LCD, this one, as you see. We multiply each one by LCD, and now we do the cancellations. X cancels by x, and then we have x minus 3 cancels by x minus 3. We have x minus 3 cancels by x minus 3, and then x plus 3 cancels by x plus 3. So now from this side, this is, we know, 3 times, that one is x squared minus 9. These two, product of x minus 3, x plus 3. Then we have negative 2 times x plus 3. And then at the right side we have negative 12 times x. Now we need to simplify this more. That's going to be 3x squared minus 27. From here I have x squared but multiplied by 2, so I have minus 2x squared, and also I have 2x multiplied by plus 3. That's going to be negative 6x. On the right side we have negative 12x. So I can combine 3x squared by negative 2x squared, and I can move that negative 12x to the right side by simply adding 12x to both sides. See, like these two will cancel. So here we go. We come up with x squared plus 6x minus 27. That's equal to 0. I think we can factor this because you can find two factors of negative 27 whose sum is 6. It's simply 9 and negative 3. So this can be factored as, just move a little bit down. This can be factored as x plus 9 multiplied by x minus 3 equals 0. So if we solve this one, x plus 9 equals 0, or x minus 3 equals 0. So we got x equals negative 9, or x equals 3. See, like we got two solutions, but be careful, that's a fraction. And in the fraction, you have numbers that can make the denominator 0. You have to take them out. Here, those numbers are, here x can't be 0. From here, x can't be 3. From here, x can't be 3, and x can't be negative 3. See, be careful with those numbers. Those are like the restrictions. You can't plug in those numbers into the original equation. So in here, this one, this 3, does not work. That makes denominator equal to 0. So we come up with only one solution, negative 9. So negative 9 is the only solution for this problem. So I hope this problem is clear. Okay, that was, see, these problems, they produce some sort of quadratic equations. But yeah. Now, the last part, earlier you can pause the video and try this problem. It's a nice one. But let's see, I mean, now you have a radical. In the radical type of problems, folks, try to isolate the radical first. That's what you need to do first. So I'm going to subtract 2x from both sides. See, these two will cancel. And now what I have at the left side is square root of 2 minus x. And the right side, I have 1 minus 2x. Now, since I want to get rid of the radical, now I can square both sides. So simply square both sides. So what do I have? Here, I will come up with 2 minus x. On the right side, please don't forget, this is squared. You need to use the FOIL. So 1 times 1, it's 1. Then I have negative 2x and then another negative 2x. And then plus 4x squared. So this is what I come up with on the right side. So this is like 1 minus 2x squared. So on the right side here, I come up with 4x squared minus 4x plus 1. Now let's make this side 0. So I can subtract 2 from both sides so that these two will cancel. And I can also add an x to both sides so that these two will cancel. So on the left side I got 0, the right side I got 4x squared minus 3x plus, oh, I'm sorry, not plus, that's minus 1. Now remember, when we do the factoring, if you try, you can get negative 3 by using 4 and negative 1. Like, for example, for the factors of these two, if you write 4x squared, if you write 4x and x, and for the other one, if you write negative 1 and 1, you can take 4x, multiply it with negative 1, that will make negative 4x, and then x times 1 is x. So if you combine, you get negative 3x. So you can factor this with this way. So it's going to be 4x plus 1, and then x minus 1. You can check that. It will give you 4x squared and then negative 4x and then plus x, which will make negative 3x, and then 1 times negative 1 is negative 1. So that works. So it's a quick trial and error, but really the point is that you try to get the middle term when you FOIL. So from here we got 4x plus 1 equals 0, or x minus 1 equals 0. And 4x equals to negative 1, so x equals negative 1 over 4, or x equals 1. Now the point is this, like in the radical case, like in the fractional case, if you have a radical, folks, don't forget the radical, inside the radical you can only have non-negative values. So you have to make sure that these numbers simply work out well in the original equation. You have to check that. This causes sometimes like problems. I mean, for this problem, because of this 2x given in here and move to that side, you have 1 minus 2x. You see, if you plug in 1 in here, you're going to get the, and of course, don't forget the square root of a itself needs to be positive. So it can't be negative. It's defined to be positive. So whenever you come up with inner part to be negative or the outcome of a radical to be negative, then you should stop. That's not a solution. So we have to check these solutions. It's like the fractional case, the rational equation case. So let's check them. Let's check them. So in the original one, the original equation was square root of 2 minus x plus 2x equals 1. Now let's check them. Check these. So if x is 1, what happens? We have square root of 2 minus 1 plus 2 times 1, is that equal to 1? So you'll see that's like square root of 1, which is 1, plus 2, is that equal to 1? That doesn't work. So so this is not a solution. So x equals 1 is not a solution. You find that. And then now in the other one, if you plug in x equals negative 1 over 4, you got radical 2 minus negative 1 over 4 plus 2 times negative 1 over 4. Is that equal to 1? Here in the first one, don't forget the problem was this: the output of a radical can't be negative. That is 1, this works, but this plus 2 will make the right side negative, and that doesn't work. That's the problem. As I said, the radical, the expression inside the radical and the output of the radical, or the square root, should be positive. So now from here you can compute that it's 4 times 2, 8 plus 1, 9. So that's like square root of 9 over 4. Plus minus, that's minus 1 over 2. Is that equal to 1? That's the question. This is 3/2 minus 1/2. Is that equal to 1? That's right, it's 1. So that means negative 1 over 4 is the solution. So from this set, by looking at the check, we can just say only solution is negative 1 over 4. 1 is not a solution. So I hope this example is clear. This is the method for square root equations or radical equations. You try to isolate the radical and square both sides. But for the radical and the rational equations, please don't forget to check your answers at the end. You don't need that for quadratic or linear equations, but for radical and rational equations, you have to do it. You have to check it. I hope you like the video. Thanks for watching. Bye.